Questions 21 through 25 on the 2015 Grade 12 AMC 12B. Cozy the cat and Dash the dog are going up a staircase with a certain number of steps. However, instead of walking up the steps one at a time, both Cozy and Dash jump. Cozy goes 2 steps up with each jump, though if necessary, he will just jump the last step. Dash goes 5 steps up with each jump, though if necessary, he will just jump the last steps if there are fewer than 5 steps left. Suppose that Dash takes 19 fewer jumps than Cozy to reach the top of the staircase. Let S denote the sum of all possible numbers of steps this staircase can have. What is the sum of the digits of S? So we have Cozy and we have Dash, so cat and dog. And the possible choices are 2x, meaning that's the number of jumps, x, and 2 represents the number of steps each jump has. And in addition, you can have no additional steps. But there's another possibility where you have 1 additional step, right? So those are the 2 possible ways that Cozy the cat can jump up these stairs. For the dog, it's 5y. Well, y is the number of jumps, and 5 is the number of steps the dog jumps. But for 5y, there's several scenarios. There's 5y plus 0, 5y plus 1, 5y plus 2, plus 3, and plus 4, because you can have 1, 2, 3, or 4 additional steps, and that will require 1 additional jump. So we are also told that y plus 19 is equal to x. So right here, Dash takes 19 fewer jumps than Cozy. All right, so the good news is that we have to equate these. That is going to allow us to solve these variables. So let's do that one at a time. So our scenarios are as follows. The first one is if you have 2x for Cozy the cat, and then we have 5y for the dog. The other one is 2x and 5y plus 1. And then, of course, 2x and 5y plus 2, 2x and 5y plus 3, and 2x and 5y plus 4. And then we also have to talk about all the 2x plus 1 scenarios. 2x plus 1 can equal either 5y. 2x plus 1 can equal 5y plus 1. 2x plus 1 is equal to 5y plus 2. And 2x plus 1 is equal to 5y plus 3. And 2x plus 1 equal to 5y plus 4. Now, what I'm going to do is I'm just going to concentrate on the ones that give integer solutions, and the rest you can do on your own. I'm just going to do these ones since that just saves a little bit of time. So the other ones don't give integer solutions for y or x, or for both, or for 1. So obviously the number of jumps has to be an integer. So that's why these 3 that I put a check mark on are the only ones I'm going to do. So let's talk about the first one. In this case, the number of jumps that the cat makes is x, but the number of jumps the dog makes is actually y plus 1. He's going to make 5 y jumps that are 5 steps each, but then he has to make 1 additional jump to cover that last step. So the number of jumps he has to make is y plus 1. So this formula has to be modified a little bit. It's still going to be y plus 19 is equal to x, but instead of y, you're going to put y plus 1. And then plus the 19 is equal to x. So y plus 20 is equal to x. Okay, so now we're going to substitute that into here. So it's 2 times y plus 20 is equal to 5y plus 1. So that becomes 2y plus 40 is equal to 5y plus 1. And therefore 39 is equal to 3y, and therefore y is equal to 13. So y is equal to 13. So that means x is equal to 13 plus 20, which is 33. And now we can figure out the number of steps. Well, the number of steps is just 2x. So the number of steps is 66. You can also figure out the number of steps by putting y equals 13 into there, which would also give you 66. So that is one possible value for the number of steps. Okay, so now let's go to this one here, down here. Again, the number of steps that the cat takes is x, or the number of jumps, I should say. It's kind of, I don't want to make this confusing. The number of jumps the dog takes is y, but he has to take one additional jump. So he has to take y plus 1 jumps. So in a very similar way to the previous one, x actually is going to be y plus 20. So substitute that in, just like the previous one, we get 2y plus 40 is equal to 5y plus 4. So that means 36 is equal to 3y, and therefore y is equal to 12. And now the number of steps, well, you can figure out x, that's going to be 32. So the number of steps, we can put x into that formula, and we get 64. So now we have another value for the number of steps. And all the other ones don't give integer values, that's why I'm skipping over them. Now the only other one that gives an integer value is this one. So this one, the number of jumps is x for the cat and y for the dog, but because we have to jump once more for each of them, the number of jumps is actually x plus 1 for the cat and y plus 1 for the dog. So that formula up here actually becomes y plus 1 plus 19 is equal to x plus 1. But what's interesting is that when you do the math there, it just goes back to the same formula, which is y plus 19 is equal to x, because both sides had a 1. So substitute that in here, and we get 2y plus 38 plus 1 is equal to 5y plus 3, like that. So this gives me 39 minus 3, 36 is equal to 3y. So y is equal to 12. To get the number of steps, I substitute y equals 12 into here, and when you do, you get 63. So there we go. That is the only other integer value. So now I'm asked to add up these guys, and then the sum, I have to find the sum of the digits. So the sum, first of all, is 66 plus 64 plus 63. And that is 193. And now I have to find the sum of the digits of this number. So the sum of the digits is 1 plus 9 plus 3, which is 13. And that is the answer to the question. So, number 21, the answer is D. 6 chairs are evenly spaced around a circular table. One person is seated at each chair. Each person gets up and sits down in a chair that is not the same chair and is not adjacent to the chair he or she originally occupied, so that, again, one person is seated in each chair. And how many ways can this be done? Let us make a little diagram, and let's say the positions are labeled A through F. So A, B, C, D, E, and F, each letter representing one of the 6 people. And then what we can do is we make a little table, a 6x6 table that talks about the different possible permutations. Now, initially, of course, we have A, B, C, D, E, and F, right? Now, we want them to move to spots that are allowed under the conditions of the question. So, for example, A cannot go to A, cannot go to B, and cannot go to F. It has to go to one of these 3. Those are the conditions of the question. Each person gets up and sits down in a chair that is not the same and is not adjacent to the chair he or she was originally occupied. So the only choices for A are E, D, and C. So we put A's there because that is where A can go. Similarly, B can go here, here, or here, correct? It can't go where it already is, and it can't go to the adjacent spot, so it can go F, E, or D. So F, E, or D is where we put B. And similarly, you get the point. We put the other ones where they can go. So C can go either E, F, or A. D can go in A, B, or F. E can go in A, B, or C. And finally, F can go in B, C, or D. Now what we have to do is we have to look for the permutations. And we are essentially trying to figure out permutations so that we use one letter from each column. So, for example, one such would be C, D, E, F, A, B. So A goes to C, B goes to D, C goes to, sorry, this should be an E, C goes to E, D goes to F, E goes to A, and F goes to B. So if that is done, that is one such permutation. And we have to find how many of these there are. Well, I will list them for you. And here they are. So as you can see, the one I made, C, D, E, F, A, B, is the first one right here. And similarly, these are all the other ones. And when you count them all up and you made a complete list, you will have made 20 of them. So number 22, the answer is D. A rectangular box measures A times B times C, where A, B, and C are integers, and one is less than or equal to A, less than or equal to B, less than or equal to C. The volume and surface area of the box are numerically equal. How many ordered triples A, B, C are possible? All right, well, if the volume and the surface area are equal, that basically means that A, B, C is equal to 2A, B plus 2AC plus 2BC. Divide everything by 2ABC, and when you do, you get 1 over 2 is equal to 1 over C plus 1 over B plus 1 over A. Now, keep this in mind. This inequality is very important, that 1 is less than A is less than B is less than C, or equal to. So that basically means that A must be greater than 2, because these are all positive. A, B, and C are positive. The only way that 1 over A plus these guys can be equal to a half is if A is greater than 2. If A was equal to 2, there's no way you could add two positive numbers and have it be half. And similarly, if A was 1, there's no way that could happen. If it was negative, you could, but A, B, and C are all positive. So A's got to be greater than 2. And that basically means that A has to be greater than or equal to 3. Now, from that inequality, 1 is less than or equal to A, less than equal to B, less than equal to C. If we flip it, we get the following. You get that 1 over A is greater than or equal to 1 over B is greater than or equal to 1 over C. So that means that 1/2, which is equal to 1 over C plus 1 over B plus 1 over A, if C is less than 1 over A, right? 1 over C is less than 1 over A. That means I can write it like this. This is less than 1 over A. Similarly, this is less than 1 over A. And then this is 1 over A. So this can be written like this, which is of course the equivalent of 3 over A. So 1/2 is less than or equal to 3 over A. So if you cross multiply, you get A is less than or equal to 6. So we have our parameters now. If we combine them, A has to be either greater than or equal to 3 or less than or equal to 6. So A can only be 3, 4, 5, or 6. Those are my values for A. And now I have to figure out values for B and C to get the ordered triples. Okay, so here we go with B and C. If A is equal to 3, we need a system to figure out the values of B or C. You can substitute it in here and figure it out, but that would take a little bit of casework or might be very time consuming. So what I'll do is try to come up with something that I think might help and proceed from there. And that equation I'll come up with is as follows. From the top we have ABC is equal to 2AB plus 2AC plus 2BC, right? What we can do is bring one of those over, say 2BC, and that leaves me with just 2AB plus 2AC, and then we can factor this guy, factor out a BC, and when you do, you get A minus 2, and this one you can factor out a 2A, and you get B plus C. So this equation hopefully will help. So we will use this throughout. So when A is 3, we get basically BC is equal to 6 times B plus C. And then if we do a little bit of fancy algebra, bring this over like this, and then if we try to factor, it can be facilitated by adding 36 to both sides, and we can factor into B minus 6 times C minus 6 is equal to 36. And then this will allow us to get our ordered triples A, B, C with a little bit of experimentation. And when you do, well, the A is 3, so we can use, say, 7 and 42. I mean, I hope that when I put it in that form, it makes it easier to figure out B and C. We got 8 and 24, 9 and 18, 10 and 15, and 12 and 12. And of course, the A's are always going to be 3 here. So I got 5 ordered triples here. All right, let's proceed in the exact same way, but this time for A equals 4. If A equals 4, again, using this formula down there, we get 2BC is equal to 8B plus C. And then if we divide through by 2, of course, BC is equal to 4B plus C. Put everything on one side and do a little bit of factoring. It will help us factor if we add a 16 to both sides. And when we do, we get B minus 4 times B minus 4, C minus 4, I should say, is equal to 16. So now let's figure out our ABCs here. And again, the hope is that doing this fancy algebra helps you figure out the ordered pairs. And you get 5 and 20, 6 and 12, and 8 and 8. And of course, A here is 4. So I got 3 ordered triples. Moving right along, we got A equals 5 now. And again, using that formula down there, we get 3BC is equal to 10B plus C. And therefore, if we multiply both sides by 3, we get 9BC is equal to 30B plus C. And therefore, 9BC minus 30B minus 30C. And then if we add 100 to both sides, it helps with the factoring a little bit. And when you do factor, you get 3B, 3C, 10, and 10. And again, the hope is that factoring will help you recognize the triples. And in this case, there's only one that is 5 and 10. And the value for A is 5. And finally, we have one last one. That is A is equal to 6. And when a is 6, it becomes 4bc is equal to 12b plus c. And that becomes bc is equal to 3b plus c. And again, bc minus 3b minus 3c. If we add a 9 to both sides, it helps us factor. Becomes b minus 3. C minus 3 is equal to 9. And let's see what we get for our ABC. I think we get just 6 and 6 is our only possible way of doing this. And of course our A is 6. So there we go. We have 5 here, 3 here. That's 8, 9, and 10. We have 10 ordered triples. So number 25, the answer is 10, which is choice B. 4 circles, no 2 of which are congruent, have centers at A, B, C, and D, and points P and Q lie on all 4 circles. The radius of circle A is 5 over 8 times the radius of circle B, and the radius of circle C is 5 over 8 times the radius of circle D. Furthermore, AB is equal to CD equals 39, and PQ is 48, and let R be the midpoint of PQ. What is AR plus BR plus CR plus DR? First, let's draw a diagram of just 2 circles, the one that have the center A and B. So this is going to be A, and this is going to be B. And since they point P and Q are the points that are common, those are P and Q, the points of intersection. And initially I'm just going to concentrate on 2 circles. It just makes the question easier to explain. Now, when I join P to Q, of course, that becomes PQ. And when I join A to B, that will cut PQ in half. And therefore, that point that it's cut in half is R. It's the midpoint. Now I will start to label a few things. I need to join a few lines here first. A needs to be joined to P. B needs to be joined to P. And now I think I'm ready to label. A to P is the radius of that circle, so I'll just call it X for now. And we are told that the radius of circle A, so RA, is equal to 5 over 8, the radius of circle B. So since I'm using just a simple variable x, I'll just put that in, and then I can get an expression for the radius of B in terms of x. It's basically going to be 8x over 5. And that is the radius of circle B in terms of x. Okay, so now we have some Pythagorean relationships. And let's see what other information is helpful to us. A to B, they tell me, is 39. Okay, that's pretty helpful. So A to R, this distance here, I will just call y. And therefore, that distance from R to B will be 39 minus y. Okay, and P to B, which is the radius of circle B, I have figured out as 8x over 5. And PQ, they told me, is 48. R is the midpoint, so that means P to R is 24. All right, and of course these are right angles. So now we definitely have some Pythagorean relationships. The first triangle will be y squared plus 24 squared is equal to x squared. And from the second one on the right side of PQ, we get 39 minus y all squared plus 24 squared is equal to 8x over 5 squared. All right, so we've got 2 equations. We can label them, let's say, call this one equation 2, call this one equation 1, and let's see how much we can eliminate by subtracting them. If I subtract them, I can eliminate quite a bit here, I think. First, let's expand this out. This is going to be 39 squared minus 78y plus y squared plus 24 squared is equal to 8x over 5 all squared. Okay, now I can do 2 minus 1. And when I do, all I'm left with is 39 squared minus 78y. And on this side, it will be 64x squared over 25 minus x squared. And when you simplify this, you get 39 squared minus 78y. And this one will give you 39x squared over 25. Divide through by 39, and you're left with 39 minus 2y is equal to x squared over 25. Okay, so that's some pretty decent progress. Now what we can do is we can substitute that into here. So that equation was y squared plus 24 squared is equal to x squared. But x squared we can get from this equation in terms of y. It's basically 25 times 39 minus 2y. Right? So let's work with this now. When you expand this, you get y squared plus 24 squared. Put everything on one side eventually, but let's just expand it. 25 times 39 minus 50y. Now we can put it all on one side. Y squared plus 50y. And then when you do the math with those numbers, you get minus 399. And that's equal to 0. The good news is this factors nicely. 57, 7, plus minus. So y is 7, because y obviously has to be a positive number. Okay, if y is 7, then we just got the value for AR. If you look at that diagram, it's 7. And then BR is 39 minus y, according to that diagram, and that would be 32. So we got AR and we have BR. So we have 2 of the 4 that we need. So we're 50% done with the question. Now we're going to move forward and do pretty much the same thing for the other 2 circles. Now the other 2 circles look a little bit different. And the reason is because the question told you the circles are not congruent. You can't make the exact same diagram as before. They have to look different. That's what it means that when they say they're not congruent. Now let's label this. This will be the center of the smaller circle, I should say. And this approximately will be the center of the larger one. And this is C and this is D. And this is P and this is Q. Those are the points that they pass through. Let's join P to Q like that. And therefore, we need to join now C to D and to that point, which of course is the midpoint, and that is R. Now, as before, let's draw our radii from C to P and from C to D to P. Okay, let's start labeling now. We are told, as before, that the radius of C is 5 over 8, the radius of D. So let's do some labeling. Let's call CR, we'll call it W. And then CP, doesn't really matter what letters you give, I'm just going to call it Z. And then DR, well, CD, they told me in the question, is 39. So DR will be W plus 39. So let's just list them all here. CR I call W. CP, which is essentially the radius of that circle, is Z. And then DR is 39 plus W. And then now, using this formula, I can get something for the radius of D. Well, the radius of C I had called Z. So the radius of D will be just 8Z over 5. So this will be 8Z over 5. All right. Okay, now again, just as before, we've got some Pythagorean relationships. So the first one, and our PQ is 48, so half of that is 24. very similar to before. All right, so now let's start our Pythagorean relationships. W squared plus 24 squared is equal to Z squared. And from the bigger triangle, we get W plus 39 squared plus 24 squared is equal to 8Z over 5 squared. So this is equation 1 again, and we'll call this equation 2. And very similarly, I will see what I get when I subtract them. And let's do a little bit of simplification before we subtract them. Expanding this, W squared plus 78W plus 39 squared plus 24 squared. And this is 64Z squared over 25. Okay, now we can subtract. And when I do, a lot of stuff cancels. I'm just left with 78W plus 39 squared. And on this side, I am left with 25 minus 64, so it'll be 39Z squared over 25. And as before, I can divide through by 39, and that will work out very nicely. It'll just be 2W plus 39 is equal to Z squared over 25. All right, so now I can substitute that into here. So that gives me W squared plus 24 squared is equal to Z squared. But Z squared I can get from here. That's 25 times 2W plus 39. Expanding this, W squared, 24 squared, 50W plus 25 times 39. And then if you put everything on one side, you get W squared minus 50W. And when you add those numbers, subtract those numbers, you get 399. And this factors also very nicely. It's WW 57, minus plus. So from this, obviously, W is 57. And remember, W represented my value for CR, so that's 57. And DR was W plus 39, which makes that 96. So there we go. We got all four. So now let's add them up. AR, BR, CR, and DR. So AR plus BR plus CR plus DR. AR was 7, BR is 32, CR was 57, DR is 96. And when you add that all up, you get 192. 192 for this very cool question, number 24. The answer is D. A bee starts flying from point P0. She flies 1 inch due east to point P1 for j greater than 1. Once the bee reaches point Pj, she turns 30 degrees counterclockwise and then flies j plus 1 inches straight to the point Pj plus 1. When the bee reaches P 2015, she is exactly a times root b plus c times root d inches away from P0, where a, b, c, and d are positive integers, and b and d are not divisible by the square of any prime. What is a plus b plus c plus d? Well, first let's draw a very basic drawing to get an understanding of what's happening. So first, we are going to start here. And this is going to be, of course, P0. And from there, we traveled 1 unit. And then we get to P1. And then from there, we have to kind of tilt 30 degrees. So this is basically 30 degrees in here. But this time, we have to actually go a little bit farther because we have to go 2 units this time. So we're traveling a little bit farther this time. So that is going to be 2. And then again, we have to now shift or tilt another 30 degrees. So if this is continuing, we have to go 30 degrees from that. So approximately something like this. Like that. But we've got to go 3 this time in terms of our units. So this is P2 and this is P3 right here. And so on, right? You just keep on going like that. So I just wanted to give a very basic understanding of the question. Now you say, okay, well, how do I approach this? Our goal is to go from P0 all the way to P2015. In this diagram, I just showed you from P0 to P3, but we got to go all the way to 2015. And when we do that, eventually, what will happen is that we have traveled a certain distance in the x direction and a certain distance in the y direction. So in the end, we will take the distance in the x direction and the y direction and figure out the total distance using Pythagoras. So for example, if we had gone this much in the x direction and this much in the y direction, the total distance from P0 to P2015 will be calculated by a simple Pythagorean relationship. So we're going to first concentrate on this x distance, then on that y distance individually. So let's first talk a little bit about the x direction. When you're going from P0 to P1, well, that was very simple. It's just 1. And when you go from P1 to P2, okay, now we have to figure out what is my x direction. And that is where the angle comes into play. It's going to be 2 cos 30. That calculates my x direction from there to there. And just to be consistent, this was cos 0 actually. You don't really need to put that in, but it maintains some consistency with what I'm writing. Now, from P2 to P3, it's 3, but cos 60 this time, right? Because if you look at this angle is 60 degrees. And then in a very predictable way, from P3 to P4, it will be 4 cos another 30 degrees you tack on, and so on. So it just keeps on going like that. In a very similar way, if you look at the y direction, it would be 1 sine of 0, and then 2 sine of 30, and then 3 sine of 60, 4 sine 90, and so on, dot, dot, dot. And then we have to keep going all the way until we get to P2014 to P2015. But the good news is that there's a bit of a pattern here, and that's what I have to explain. So what I'm going to do is concentrate solely on the x direction, and then once we get the x direction, we can talk about the y direction. So the total sum, what I had written was 1 cos 0 plus 2 cos 30 plus 3 cos 60 plus 4 cos 90, and you get the idea, right? But then we have to start thinking a bit, because we obviously are not going to write it all out. That would be, impossible. But we have to start thinking at what this is going to be. Eventually, when you get to 12, it's cos of 330, all right? And then 13 is cos of 360. But then, once you get to 360, you've gone one way around. So then it goes back to 0 again, cos of 0, right? 14 cos of 0, and so on, 15 cos 30, and you get the point. Dot, 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 and then I'll extrapolate all the way until the very end. Now, 2016 is not what we're going to get to, but the reason I wrote that is because every time it's a multiple of 12, it'll be cos 330. 2016 is an interesting number. Why? Because it is a multiple of 12. Exactly. So if it was in there, it would be 330 cos. But we're not going to that, so we don't need to include it. I just wanted to put it in there as a frame of reference. So one before it, which is what we definitely will include, will be the cos of 300. Okay, so that is how we get this whole thing. So I hope that makes sense. Now what we have to do is we have to adjust these angles. When you move right at theta degrees, it's the same as moving left at theta minus 180 degrees. So all of these can be adjusted as follows. We can keep the 1 cos 0, 2 cos 30, 3 cos 60, and all those guys, right? 4 cos 90, and so on. We can keep 5 cos 120, 6 cos 150. But once we get to 180, it's the same as 180 minus 180, which is 0, but in the opposite direction. So instead of 7 cos 180, it becomes negative 7 cos 0. So this is a very important point that allows us to simplify this. And then 8 cos 30 minus 8, and so on, dot, 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 until you get to 2015 cos 120. Now at this point, we have to carefully group like terms. So in front of all of the cos zeros, we have to put the proper numbers. And that is going to be 1 minus 7, and then plus 13, dot, dot, dot. And then eventually you will get plus 2005 minus 2011. And then we group what is next, which is cos of 30. And that's going to be 2 minus 8 plus 14. And then eventually you will get dot, 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 2 plus 2006 minus 2012. So let's continue in this fashion. Then we have the next one, which is going to be 3 minus 9 plus 15, dot, 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 and eventually you'll get to 2007 minus 2013, and that is cos 60. Then we get to the next one, 4 minus 10 plus 16 minus dot, 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 2008 minus 2014, and that is cos of 90. Then we get to 5 minus 11 plus 17, dot, 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 plus 2009 minus 2015, and that is cos 120. And I think there's one last one, plus 6 minus 12 plus 18 minus dot, 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 plus 2010 minus, I think that's it. We actually minus 2004, let's just put it 1 before, plus 2010. And then that says cos 150. All right, so we have grouped this very nicely. Now comes a little bit of a magic. Not really, but all of these, if you notice, are minus 6, dot, 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 minus 6, right? Cos 0. And then we're adding again minus 6, dot, 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 minus 6. And you get the point. You don't need me to walk you through every single one. So I'll just write them all out. Cos 30. So now that we've got these all grouped into minus 6's, we have to start adding them. Well, how many were there? If you go back and actually look at the terms, you'll see that if you do that count, it's 336 terms. So there's 336 terms that were here. Right there, 336. And this was also 336. This was also 336. from here to here was also 336. This was 336. And if you notice here, it actually didn't increase. It didn't go up to 2016. So this actually is only 335. And that's a very important point to assess. So I'll just write X. I'll just continue over here since it keeps it all on the same screen. So that means these guys, there's 336 divided by 2 of those negative 6's, because to get a negative 6 you had to combine 2. So since there was 336 terms, there's 336 divided by 2 of those minus 6's. So cos 0. And similarly, it'll be 336 divided by 2, which is 168, times minus 6, cos 30. And very similarly, 168 times minus 6, cos 60, plus 168 times minus 6, cos 90, plus 168 times minus 6, cos 120. Now the last one is the only one that is a bit tricky, because there's only 335, so that would mean there's 167 of those pairs, right? But then there's an additional one guy left over at the end without a pair, because there's no 2016 to subtract, so you just have to put that in there like that. Cos 150. All right, so significant progress is being made. Let's continue here. So we're going from here to here. And now we just have to multiply all these out. So it becomes minus 1008 cos 0 plus, or actually minus, they're all going to be minus 1008 cos 30, minus 1008 cos 60, minus 1008 cos 90, minus 1008 cos 120, and then this one is a little bit different, right? This one, when you do the math, it actually becomes plus 1008 cos 150. Okay, now all we have to do is factor out a minus 108 and then just now write out what is the values of all of these numbers. Well, the cos of 0 and so on. And this is going to be 1 plus root 3 over 2 plus 1/2 plus 0 minus 1/2 plus root 3 over 2. And when you add all these up, it just becomes 1008, and everything in the brackets there simplifies to, well, these two cancel, and then it just is 1 plus root 3. And there we go. All that hard work to get the final answer for x. But we also need to get y, remember? Y direction, all the way at the very end here. Well, the good news is that it pretty much is the exact same pattern. And yeah, I'll let you do that. I don't think you need me to talk you through it since it's identical. And when you do, at the very end, you'll get a very similar identical number, which is minus 1008 plus 1 plus root 3. All right, so now we have to use this formula right here. This d is equal to x squared plus y squared, right? So we had our x value as minus 1008, 1 plus root 3 after all that hard work. Y you get it by doing the exact same process, so I'll let you do that. And now we just have to figure out the distance with that formula. So plug that in, x squared plus y squared, and we get minus 1008, 1 plus root 3, all of this squared, plus y squared, which is again 1008 times 1 plus root 3, all squared. And this is all under the square root sign. So these are identical, so it just becomes really 2 times 1008 squared plus 1 plus times, I should say, 1 plus root 3 squared, all under the square root sign. So that becomes root 2 1008 1 plus root 3. If you multiply this out, you get 1008 times root 2 plus 1008 times root 6. And if you remember at the very end, or very beginning, I should say, that they told me that that distance is of the form a times root b plus c times root d, and they wanted you to figure out a plus b plus c plus d. Well, a in this case is 1008, b in this case is 2, c is 1008, and d in this case is 6. So that's 2016 plus 8, which is 2024. So that is the answer to a very challenging question, number 25. The answer is B.